What's up, everybody? We are now in section 4.2, in which we're going to talk about congruence and triangles. So, let's look at our goal for this lesson, the first goal anyway. The goal for this lesson is that you will use corresponding parts of triangles in order to determine whether pairs of triangles are congruent to one another. Now, we've talked about in the past how you know that segments are congruent, how you know that angles are congruent. Now we're going to start looking at figures in general, where you could look at triangles or rectangles or pentagons, those kinds of things, to determine if they're congruent. And it's going to involve using these corresponding parts of triangles in order to determine, or of other figures, in order to determine whether they're congruent to one another. All right, now there's some basic stuff that we need to talk about, and this is a little bit more of a reminder of like I was just doing a moment ago, actually. Recall that if you have two segments that are congruent, what that means. What we said it means that if two segments are congruent is that they are equal in length, or they have equal lengths to one another. So as long as this distance equals this distance, then this segment is congruent to that segment. Now, very similarly, we've talked about what it means for two angles to be congruent. And what it means for two angles to be congruent is for their angle measures to be congruent, right? For that measurement and this measurement to be the same. Have equal angle measures. All right. So we need to build on those two definitions in order to figure out what it means for two figures to be congruent to one another. All right, congruent figures. Two figures are congruent if and only if. All right, now I'm going to have a picture of a couple different figures over here, and then I'll complete that statement. It's not complete quite yet. Two figures are congruent if and only if. All right, well, let me throw this to you to think about. Are these figures that I've drawn, first of all, congruent to one another, and how do you know? Well, apart from actually measuring, they look congruent, don't they? Don't they look like they're exactly the same size and exactly the same shape? And that's a good description of what congruent figures are, is figures that are the same size and shape. All right? Now, how do we determine if two figures are the same size and shape? Well, we use what are called the corresponding parts of those figures in order to make that determination. Now, you're used to the term corresponding angles in regards to two lines cut by a transversal. Now we're going to use the word corresponding in a whole different context, in which we might be referring to corresponding sides of a figure or corresponding angles of a figure. All right, now corresponding sides would be two sides that are in the same position on two different figures. For instance, segment AB and segment EF would be corresponding sides. And then corresponding angles would simply be the angles that are in corresponding positions for two different figures. All right, so angle C, for instance, would correspond with angle G. And the only way that these two figures can be congruent is if all of the corresponding sides of the two figures are the same length and all of the corresponding pairs of angles are congruent to one another. So that's our definition. Two figures are congruent if and only if every pair of corresponding sides and every pair of corresponding angles are congruent. In this picture, that means this. Segment AB would have to be congruent to segment EF, and segment BC would have to be congruent to segment FG. Segment CD would have to be congruent to segment GH. Segment AD would have to be congruent to segment EH. That's all the pairs of corresponding sides would be congruent to one another. And angle A would have to be congruent to angle E, angle B congruent to angle F, angle C congruent to angle G, and angle D congruent to angle H. Every pair of corresponding angles must be congruent, along with every pair of corresponding sides. And in that instance, when that's true, the two figures, in this case quadrilaterals, are considered to be congruent to one another. Now that means that they're exactly the same size and same shape if all their corresponding sides are the same length and all their corresponding angles are the same measure. Hopefully you're starting to get that definition to your head right now. So, for this video, what I'm needing you to be able to do is basically describe which figures, if any, are congruent within a picture, and then I need you to be able to identify the corresponding parts of those figures that help you make that determination. I've got a pair of triangles here, and you can see the directions are saying to write a congruent statement for the triangles, and then identify all pairs of corresponding parts. Alright, well, let's take a look at the two triangles then. You're going to notice that I've got a lot of markings on these triangles. Alright, you see that, for instance, segment KG is congruent to segment BT. Segment GR is congruent to segment BM. Angle K is congruent to angle T, and so forth. I've got markings to indicate which pairs of sides and angles are congruent. Now, one of the things that I want you to know about congruent figures is that they are always transformations of one another. For instance, I'm going to draw another line in this picture. Could you imagine how if I were to flip this triangle in that line, it would make this triangle? Alright, so if you could map one figure onto another by a flip or a rotation, seems like there's one more of those, but it eludes my memory right now, then, or just a simple slide, then the two figures are going to be congruent to one another. And if you can imagine which kind of transformation would map a figure onto the other one, then it helps you identify the corresponding parts, which is necessary for this whole gig. Alright, with this reflection, you see how this, if I flipped it over the line, would correspond with that angle. Angle R would correspond with angle M and so forth. Great. So that's a little knowledge that we need to have. Let me get on to writing the congruent statement right now, though. What a congruent statement is a statement which says what are the names of the two figures that are congruent, and it also shows you which parts of those figures are congruent to one another. So let's write the congruent statement for this pair of triangles that are congruent to one another. Now, a new symbol for you to learn is this triangle symbol. Remember how we had a symbol for angles, we had symbols for line segments and everything? Anytime you're trying to name a triangle, you can just use a little triangle symbol like that. And let's say that we give the name triangle KGR to this first triangle. Alright, now my congruent statement is supposed to tell me the names of the two congruent triangles, and we call the first one triangle KGR. But the other thing the congruent statement does is it shows you which pairs of sides and angles are congruent to one another. It's easiest to do this with angles. You see how I put angle K first when I named triangle KGR. Now that was arbitrary. But what I'd like to do is figure out which angle from the second triangle corresponds with angle K. And if you imagine that flip, then as we've discussed already, you know that angle T corresponds with angle K, right? Similarly, I put angle G in the middle of the name for triangle KGR. That was arbitrary. But since I put it in the middle, I need to put its corresponding angle, B, from the other triangle in the middle as well. And then angle R from the first triangle corresponds with angle M, right? So we would say that triangle KGR is congruent to triangle TBM. As long as the corresponding parts are in the same order, doesn't matter what you call the triangles. So that's a congruent statement. Now let's go ahead and do the identifying all pairs of corresponding parts. We've done it verbally already, but we do need to write it down. And I like to do this by just identifying the corresponding sides and then identifying the corresponding angles. The corresponding sides, let's start with segment KG. Can you see how segment KG corresponds with segment TB? And if you see that, go ahead and name the other pairs of corresponding sides. I'm just going to list them right now. I think you see that segment KR corresponds with segment TM, right? Because of the flip. And similarly, segment GR corresponds with segment BM. Now, corresponding sides of figures don't always have to be congruent, but in this case they are, so I just said that each pair of corresponding sides were congruent. Then let's do the same with the pairs of corresponding angles. Now, we've already mentioned which angle pairs are corresponding, so I'm just going to list them all at once, and then you can see that you know already that those are the corresponding angles. Easy enough, right? Okay, I do want you to pay attention to the notation. Whenever I was talking about congruent triangles, I used triangle symbols to indicate that I was naming triangles. Whenever I was naming sides of figures, I used the little segment symbol to indicate that the sides are indeed line segments. And whenever I was referring to angles, I used the little angle symbol. Notation is super key. Don't forget to use the correct notation. Pay careful attention to that. Let's look at another pair of congruent figures and see some other types of things that you're going to be asked to do with them. Alright, now you see a different type of picture here altogether. And what it's wanting us to do here is to write a congruent statement for any figures that can be proved congruent and to explain your reasoning. Alright, well, I chose this example for a particular reason. It's because we're going to use this particular picture is going to use a property that we talked about way back in chapter 2, but hasn't really come up since then. I'll tell you what that property is in a moment. But first of all, let's go ahead and determine if we can prove any figures congruent here. Now, you see how this quadrilateral is divided into two triangles by drawing the diagonal. That doesn't have to make two congruent triangles, but in this case, it happens to make two congruent triangles. And how do I know it happens to make two congruent triangles? Well, look, angle P is congruent to angle R. Angle PQS is congruent to angle QSR. And angle PSQ is congruent to angle RQS, right? Meaning that all three pairs of corresponding angles are congruent. Similarly, and here's where the new the property that we're revisiting is going to come into play. We're told that segment PS is congruent to segment QR. And that segment PQ is congruent to segment SR. However, that's only two pairs of corresponding sides that are congruent to one another. So what about the third pair of corresponding sides? Well, do you notice how the third side of each triangle is this same line, segment QS? Okay, so the third pair of sides, they're actually the exact same segment as one another. Now let me ask you this question. Is it possible that segment QS is longer in this triangle than it is in this triangle? Absolutely not. It's exactly the same segment in both triangles. And so, segment QS has to be congruent to itself. And do you remember what property it was that says that a segment or an angle is congruent to itself? The reflexive property. There you go. So there are two triangles that can be proven congruent here. And so we're going to write a congruence statement for those triangles. And we're going to try to get the corresponding parts in order to do that. Now, whenever you're writing a congruence statement, just give the first triangle whatever name you want to give the first triangle. Let's call it triangle PQS. Notice again the use of the triangle symbol whenever I'm naming a triangle. And let me go ahead and put the triangle symbol actually for the other triangle that we're going to name as well. We're going to need that. Okay, now we want the corresponding parts for the second triangle to be in the same order as they are for triangle PQS. And in order to do that, we have to be able to visualize what kind of transformation would map triangle PQS onto the other triangle. And what it turns out it would be is a rotation. Now I'm just going to put something on here so you can hopefully imagine with me. Hopefully that's not hard to see. See, I put a little dot right there. Imagine that you were to rotate this triangle around that dot right there. Do you see how angle P would match up with angle R? And that this angle would end up getting over to there with the rotation, and this angle would end up going over there. So these two triangles are rotations of one another. Now, how does that help us with the congruent statement then? Well, we said that angle P went first for triangle PQS. We just decided that on our own. It could have been any of the three. Angle P would rotate to angle R, so those are the corresponding parts, aren't they? So when we name the second triangle, we're first going to call this, we're going to put an R right there. That's what I'm trying to do. Then, look at this angle PQS. It would get rotated around to here. And so that means angle Q from the first triangle corresponds with the angle S from the second triangle. S will go second here. And then this angle PSQ would rotate around onto angle RQS. So S from the first triangle corresponds with Q from the second triangle. It takes a lot of practice to get that. All right. Now, that was just me writing a congruent statement. It still wants me to explain my reasoning, the problem does. And so let me show you kind of how that works out. This is going to feel like a proof. It's not quite a full proof right here. But basically, whenever you're trying to say that two figures are congruent, it's because all their corresponding parts are congruent. And so you tell which parts are congruent and how you know they're congruent to one another. So let's start with the corresponding sides. I'm going to go ahead and list them all out, and then we'll talk about why they are congruent. Now, all the pairs of corresponding sides were already marked as congruent, right? Segment PQ was already marked as congruent to segment RS. Oh, you know what? Three of them were marked as congruent already. The one that was the same segment in both triangles was not marked as congruent to itself, but it is, of course. So how do we know that each pair of segments are congruent? Well, I just got done saying segment PQ is congruent to segment RS. That was given to us the entire time. The same with segment SP and segment QR. That was given. The one that wasn't given to us was the side that both triangles share right there. Now, I named it segment QS here, segment SQ there. That was just kind of because of the rotational way of mapping the first triangle onto the second triangle. But those are exactly the same segment, aren't they? And if you're ever saying that something is congruent to itself, then it's the reflexive property, reflexive, not reflective, the reflexive property of congruence that justifies that. So those are the pairs of corresponding sides that are congruent. We also need to mention that all the corresponding angles, all the pairs of corresponding angles are congruent. I'll continue that over here on the left side of your screen. Now, it's obvious that angle P is congruent to angle R after all our discussions. I want you to pay attention to the way I named the other pairs of congruent angles. Look at this. Notice I didn't just use one letter to name those angles, and that's because it's not like angle P and R where there was only one angle at this vertex and there was only one angle at this vertex. There are three angles that have this vertex Q. There's angle PQS, there's angle SQR, and there's angle PQR, and I got to be as specific as possible about which of those that I'm naming. So angle PQS, this one with the three little arcs, is the one I was trying to use, and it's congruent to this angle RSQ over here. That's why I named them the way that I did. And then finally, this angle PSQ is going to be congruent to this angle RQS. And in this picture, each of those relationships was already given, right? We already knew which angles were congruent because of the picture, so we can write given next to every one of those things. Alright, had another example here, but this video is long enough as it is. That's how you determine whether two figures are congruent to one another and how you identify the corresponding parts and so forth. I think this has probably been helpful for you. Thanks for your attention, and I will see you next time.